Have you ever wondered if the universe we live in is just one of countless parallel universes? The concept of the multiverse doesn't only appear in science fiction films, but is also one of the most significant and challenging questions in modern science. If this idea is true, it would completely change how we perceive reality, humanity's place in the cosmos, and even the meaning of existence. But does the multiverse truly exist, or is it merely an alluring hypothesis? Let's explore this idea through scientific theories, fascinating stories, and the unresolved debates surrounding it. The multiverse, also known as the many worlds, first emerged from quantum mechanics research in the 20th century. One of the earliest and most influential ideas supporting the multiverse was the many worlds interpretation, proposed by Hugh Everett in 1957. According to Everett, every quantum event doesn't lead to a single outcome, but branches into multiple outcomes, each forming a parallel universe. For example, when you flip a coin, in one universe, it lands heads, while in another, it lands tails. Both outcomes exist simultaneously and independently in their own realities. Initially, this idea was met with skepticism, as it implied the existence of infinite parallel universes beyond our perception. However, as quantum mechanics advanced, Everett's interpretation began to gain traction. One famous experiment that illustrates this theory is the double-slit experiment. When particles like electrons are fired through two slits, they produce an interference pattern, suggesting they exist in multiple positions simultaneously. However, when observed, the particles behave like solid objects, and the interference pattern disappears. This puzzling behavior raises the question, could the unobserved states of particles exist in parallel realities? Beyond quantum mechanics, string theory provides another strong foundation for the multiverse. This theory posits that all fundamental particles are not points but tiny strings vibrating at different frequencies. Interestingly, string theory requires at least 10 dimensions to work, while humans can only perceive 4, 3 dimensions of space and 1 of time. This opens up the possibility of hidden dimensions where multiple universes could coexist. One popular visualization of string theory is the concept of bubble universes. Imagine that our universe is like a giant bubble floating in a vast multidimensional space. Around it, countless other bubbles, each representing a parallel universe, could exist. These bubbles might have different physical laws, constants, and even life forms. Some might be similar to our universe, while others could be so different that they defy comprehension. Another significant theory supporting the multiverse is eternal inflation, developed by physicist Alan Guth. Guth proposed that after the Big Bang, the universe didn't just expand, but underwent a rapid inflationary phase. However, this inflation didn't occur uniformly. Some regions of space stopped inflating while others continued, creating separate patches of the universe. These patches could evolve into completely independent universes with their own structures, physics, and flows of time. Scientists have searched for evidence of parallel universes by analyzing the cosmic microwave background CMB, the faint glow left from the Big Bang. Small anomalies in the CMB data are thought to possibly be caused by interactions between bubble universes. However, proving this remains one of the greatest challenges in cosmology. Another vivid example tied to the idea of the multiverse is Schrödinger's famous thought experiment involving a cat. In this scenario, a cat in a sealed box can be both alive and dead until someone observes it. Some scientists suggest that each state of the cat corresponds to a different universe, one where the cat is alive and another where it is dead. Despite its allure, the multiverse remains highly controversial. Physicists like Michio Kaku and Neil deGrasse Tyson argue that the multiverse is an essential concept that helps explain phenomena like the fine-tuning of physical constants in our universe. They suggest that in a multiverse, there could be countless universes with different constants, and we just happen to live in one where conditions are ideal for life. On the other hand, critics like Sabine Hossenfelder argue that the multiverse is not scientifically valid because it cannot be observed or tested. They view it more as a philosophical idea rather than a testable scientific theory. Beyond the scientific debates, the multiverse has had a profound impact on popular culture. Films like Interstellar and Doctor Strange explore the concept of multiple realities, intertwining it with themes of choice, fate, and interconnectedness. These portrayals make the idea of the multiverse accessible and exciting, even if they often prioritize storytelling over scientific accuracy. In the future, tools like the James Webb Space Telescope might bring us closer to answers. This telescope is designed to observe distant regions of the universe, where unusual phenomena hinting at the existence of parallel universes could be detected. Additionally, artificial intelligence is being used to analyze vast amounts of astronomical data, opening up opportunities to uncover patterns that humans might miss. If the multiverse truly exists, it would open an entirely new chapter in the history of science and philosophy, raising profound questions about humanity's position and role in the larger cosmic framework. This would mean that we are no longer the center of a single universe, but merely a small part of a complex network of countless universes. Each universe might possess unique characteristics, distinct physical laws, and even forms of life that are unlike anything we have ever encountered. The existence of the multiverse would challenge the foundational principles of modern science. It raises the question of whether the physical laws we know are truly universal or simply part of a larger picture. Laws like Einstein's theory of relativity or quantum mechanics may only apply within our universe, while other universes could operate under entirely different principles. This would not only expand the boundaries of physics, but also force scientists to reconsider core assumptions in the field. Beyond the realm of science, the concept of the multiverse raises profound philosophical questions. If we are just one among countless universes, what does this mean for the concept of existence? It could transform how we perceive the meaning of life, fate, and humanity's role in the grand scheme of things. If there are universes where our choices lead to entirely different outcomes, does that diminish the significance of our decisions in this reality? Moreover, accepting the existence of the multiverse would encourage us to ask new questions about the connections between these realities. Could the universes interact with each other? If so, how might such interactions occur? And could they be observed or even harnessed? These ideas not only stimulate the imagination, but also hold the potential to inspire technologies and innovations that are currently beyond our comprehension. Even if the multiverse remains a hypothesis, the concept has significant value in pushing humanity beyond the limits of current understanding. It encourages us to ask bigger questions, think more creatively, and continue seeking answers about the nature of reality. This concept is not just a scientific puzzle, but an invitation for humanity to explore the wonders that lie beyond our knowledge. What do you think about the multiverse? Could it be real, or is it just a product of human imagination? Let's discuss one of humanity's greatest mysteries together.